Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Automating LLM training with TRL and SFT Trainer, a deep dive. In this discussion, we are going to look at why TRL, what is reinforcement learning through human feedback, how we are going to automate the process of fine-tuning, the three trainers that is provided by the TRL library, that is SFT Trainer, Reward Trainer, and PPO DPO trainers. And finally, we will dive into the SFT Trainer configurations and dataset requirements. This discussion is going to be about TRL library. It's called as Transformers Reinforcement Learning library, and this library provides various abstractions or classes that can automate the process of training. It can also implement certain trainers called as reward trainers, which can help the model to become much more better. Okay, what I mean by this. So let us take a step back and think about the large language model as a system that is learning. So if a system has to learn, you have to give it input, and once the system is given an input, the system takes an action. So there is an input, the system takes an action, and once the action is taken, we need to give the system a reward based on the action. If the action is good, then the system is rewarded with positive points, and if the action is bad, then we give it negative points. This is the basic tenets of the reinforcement learning. And in reinforcement learning, there is a lot of different algorithms present, and among them, the most recent development is the proximal policy observation optimization. Proximal policy optimization is an algorithm that is getting prevalent in reinforcement learning, and the same PPO algorithm can be used inside the NLP, that is used inside large language model training also. TRL library helps us in abstracting this entire process, how it is doing it, and what are the various background modules and classes we will be looking at in this video and couple of next videos. What happens in case of the TRL is they have given three different trainers. So SFT trainer, that is supervised fine-tuning trainer, then there is reward trainer, and then finally the PPO trainer that I was talking about. The DPO is direct preference optimization trainer. So these are the trainers that is offered by TRL library. We are going to look at the first one, the SFT trainer, that is supervised fine-tuning trainer, and how the supervised fine-tuning trainer works. Basically, you create a trainer object, and in that object you give a dataset path and you give a model name path. You can give either the model itself if you have the model in your hand, that is if you have created it, or else you can just give the model name path, that is the Hugging Face path. If you give both of these things to the trainer will fine-tune on this dataset based on the dataset configuration that you are providing, and it will give a fine-tuned model. Yes, you heard me right. It completely automates the fine-tuning process. And what we are going to do next is we are going to look at the varieties of SFTT configurations, and in fact, you can use quantized models also for training. So it's a huge win. So what we are going to do is right now we are going to go to the Jupyter notebook. Here we are, and this is a familiar place, right? If you guys have been following my videos right now, this will be familiar view. So here in this area, what you're seeing is the RAM usage, and here at the bottom you're seeing the GPU usage, and we have the code here. So the idea is to ensure that the memory allocations and the resource usage is properly monitored as we are trying to work on our models. So that's the intention of this particular setup. We are going to work with TRL library, and I am using 0.7.11 version. You can execute this code and you can see that. Also, if you want to kill this particular kernel, you can kill it using by closing any of these kernel that is running, or you can use the option that I recently came across. You can use the PID of this kernel and you can kill that PID using the os.kill option inside Python. So this is one of the things that I had come across, but this is very unnatural. At least here you can see that when I click, when I close this, excuse me, let me close this. When I close this particular kernel, I can see the GPU or the RAM getting released, but here it takes a bit of a time. So it's a bit of unnatural, but I just thought of giving that idea. Now we are going to work with three classes. I mean, just three classes. So we are going to use the load dataset function from datasets. We are going to work with SFT Trainer from TRL library. So you need to install the TRL library. You can just do a pip install TRL. It will take care of the needful. The point is TRL might pull a lot of supporting libraries. So if you have not installed transformers, if you have not installed PyTorch, then it is going to install all of those things for you because it's all dependencies. Here first I am showing the IMDb dataset. This IMDb dataset is used for classification operation, and most of the time I will be using a very small subset of the dataset because I am going to show you a lot of different configuration and lot of different datasets that can be trained on SFT Trainer. So I am taking the dataset, I am loading the dataset, and then I am splitting it to 20% as train and test, and from the 20% of the data I am again splitting it into test size. So test size of 10. So in this way I am only taking only 10% of the entire dataset. So if the dataset is very big, then the training time will take longer. So that's why I am not doing that. I'm not taking the entire dataset. So I'm going to start this particular, I'm going to run this cell, and this is going to download the dataset, IMDb dataset. And next I am going to create a training argument. The reason why I'm creating this training argument is I have to give the batch size here, and also the eval batch size and the train batch size. If you have been following my earlier videos, you must be knowing why. If you don't give the training arguments, and if you follow the, let us go to the documentation, and if you follow the various examples that has been provided here, if you go to where it is, I think it is here. Yeah, if you click on this, you will see that they have introduced all the various configurations here. So I'm using the same configuration. Only thing is that if you are using a smaller graphics card like mine, I am using a 12 GB RTX 4070. If your batch size is large, like 8 or 10 or 16, then you are going to get an out of memory error. So in my case, even if I go above 4, I get a out of memory error in case I am using a different kind of a model. It all depends on the model, right? And also it depends on the size of the data point. So if your size is 1024 and if your statement is very long, then that is also going to take a lot of memory. These things were analyzed. So I had come across this eval batch size and train batch size after a lot of testing. So I'll be showing you those data also. If you have seen my earlier notebooks, you would have seen that I have lots of notes and comments in my notebook that shows what challenges I faced and how I resolved that. So this dataset has been downloaded. I am going to create this training args instance, and then I am going to pass the model. So Facebook OPT 350 million is what I'm going to use. I am going to send both the datasets, train and test. If you don't send this test dataset, then it will not evaluate. So it will throw an error. So ensure that you send the test dataset separately and you give the dataset text field. So let me show you the dataset for a moment and you will be able to appreciate what's happening. Let me go into the train dataset and let me show you the first data point. So you'll see the first data point is pretty huge, and it is having a label and it is having a text, and we are going to work on this text feature. So that's our idea, and that's what we are telling to the model also. And by default, the model is going to train for, yeah, you heard me right, it is going to train for causal language model. It's not going to train for anything else. So SFT Trainer, even though it is it might look that it is going to automate a lot of options, but by default it is going to work on causal language model. So I'm going to execute this cell, and you can see that it is loading the model, it is working on the data set, it is tokenizing it, and it is doing everything in this particular cell. Yes, it did everything in that cell. And you can see that in this case, whenever I executed this particular cell, you see my GPU VRAM did not change. It did not modify at all, but my system's RAM increased. So by default, the model got loaded into the system RAM. And here you can see that I have been testing with the various batch sizes, and I was trying to understand that how much GB of GPU and how much GB of when it was creating out of memory error, etc. So all these things I have noted it here, and now I am going to do the training right now. That's it. So the training starts. It is as simple as that. Just give me a second. Sorry about that. The GPU VRAM was already getting used due to the way I had kept the layout. The memory modification was not shown in the display, but right now you can see that the training is running. The epoch is also getting updated here, and you can see that the validation is happening right now. And all these things are happening because the training arguments have been modified. If you don't give these training arguments, then you will see that it goes with the default training arguments, and if you don't have the sufficient memory, then it will fail. So now that you have seen the first training, I am going to kill the kernel. So we are going to see a lot of kernel killing in this video. So this is the first introduction. So you saw a lot of things here. We are going to continue. What we are going to do next is we are going to use an option called as DataCollatorForCompletionLMOnly. This is a data collator from TRL library that can be used for working with the different kind of data sets. So we are going to use a data set called Code Alpaca 20K. You can take a look at this data set in Hugging Face Hub. You will get a fair idea of what it is. And I'm going to execute, before I execute this cell, let me execute this particular imports. So these imports are going to work and get me the models, and this will get me the SFT trainer. Next, I'm going to get the data set, and I'm going to reduce the size of the data set for making it easy for me. And then we are looking at the data set example here. Apart from this, in this particular step, we are going to create a supporting function. So this function, we can actually pass it to the trainer. So formatting prompts function, we can create prompts. It's very similar to how we create pre-processing for sending it to data sets, right? We used to do this in our regular operation, regular training operation, where we pre-process the data set into question and answer, query and reply. So similarly, here we are taking the instructions, taking the output, and we are converting it into question, and we are converting it into answer. And this entire template, we are making it as a function. And then what we are doing is we are going to update that. So in the DataCollatorForCompletionLMOnly, we are going to send only the response template. So there is also one more type of template. We will look at it in the next example. In case of the format function, what we are going to do is the training argument is same as the earlier one, no change. I'm going to execute that. Let me execute this also. I think I forgot that. Yep. And then in this SF trainer object instantiation, we are going to send the format prompt function also. So when you are going to do this, the function will be applied on the dataset, on these two datasets, and then that will be used to train the model with the training arguments that we have provided here. All these things will be done automatically. So that's what I was telling you. It's a proper automation. So you can see the model is loaded the moment I ran this particular cell, and here again I have shown how much memory it takes. So if I modify the batch size to 3 or testing batch size to 4, it fails. So I have used a batch size of 1 and 1. So if you go up, you can see that I'm using 1 and 1 here, and executing this, the trainer starts. It's as simple as that, guys. I mean, the point is, this particular series of series of videos, I have been showing the frustrations that you can face when you're trying to train a model. But using SFT Trainer feels as if it's a real breeze. But there are challenges if you don't understand the things properly. So that's why, I'm going through the entire process, and this entire process is already present here. It's not something that I am, coming up anything new. What I am trying to do is I am trying to add the information regarding the batch sizes, the information regarding how to, work with the data sets, how to look at the data sets. So that is the primary objective that I want you to look at in this video. So here I am going to use Tim Detmer's Open Assistant dataset, and I'm going to use Facebook OPT 350. You can use any other model also. If you want to use Bloom 560 also, you can try it out and see how the model works. And it's matter of just changing this model here, and the entire setup starts working. So let us execute this dataset, and here what you're doing is there is both instruction template that is provided by the human and the response template that the assistant replies, and this is sent both to the instruction template, and response template is provided to the DataCollatorForCompletionLMOnly LM, and then we are giving the tokenizer also. So in the past, what we used to do is we have to modify the tokenizer, and we have to do we have to change the tokenizer internal workings when we are going to add additional tokens. All these things are automatically taken care by this particular data collator. So you don't need to worry about these things. And once you send this data collator to the trainer, the necessary settings are taken from this data collator and it is applied appropriately. So you have to still understand how the regular training works. So let us go back to the presentation for a second. And this presentation is an overarching presentation of all the things that I have done till now. So fine tuning and inferencing LLMs. This is the first video presentation that I have provided. And if you scroll down, you can see the training process that I had spoken about. So the dataset is provided, it is tokenized and pre-processed, and it is sent to the trainer. And the language model is also sent to it, and the training happens. So there is a loop that the data is fed into the language model, the evaluation is done, the optimizer looks at the losses, and then modifies the language model's parameters. So this keeps on happening. The same thing still continues. Nothing has changed. Internally, what the training process that you look at it here, it is all happening still. There is no difference. Only thing is that we are not able to see those things in this simple implementation. So all you are seeing is this particular class implementation. You are calling this, just a minute, let me complete this. Training arguments I have initiated, and you are calling this very simple looking class. But inside this class, all of these things. So this entire process, dataset, pre-processing, loading it into the language model, pushing it into the language model, the looping process, everything is taken care. I mean, this entire process is taken care, and it is provided to us in a simple implementation. And once I execute this, you'll see that the entire dataset processing, everything happens, and the training itself starts. It's amazing, right? But the most important point I want you to still understand is that you need to know how the actual model training has to be done manually. Only once you are clearly aware what is happening inside this SFTT trainer, you will be able to use it fluently. Or else, if you blindly try to send in the datasets, it might work for one dataset, it might work for one model, and when you are going to try for a different model, you might actually come across a different kind of an error. So that's why I am insisting on understanding how the training works, how the pre-processing and post-processing works, what are the challenges you will face. All these things has been discussed in this initial video. So fine-tuning and inferencing LLMs, take a look at that video. You will be up to speed in no time. Okay, so you saw that in this in the recent discussion, we spoke about how to use the instruction template as well as the response template together. So let us stop this and let us go to the next. So we have seen that, and next what we are going to do is we are going to work with the bigger model right now. So we are going to work with Llama 2 7 billion model, and we are going to look at how to work with the chat-based model. So 7 billion model, HF is a chat-based model, and it has got its own tokenizer, and also we are able to look at how the tokenization works. So let me execute this particular cell, and you will see that the model tokenizer, the tokenizer is getting pulled, and you can see that the sentence, the user hello assistant hi, how can I help you? So this sentence is tokenized into this way, and each of this tokenized word, subword, you can see has got a number. So all these things we can get it from this particular print tokens with IDs function. So where are we going to use this? We are going to use something called a setup chat format function. So this chat format function comes from TRL, and it does all these things. So it adds special tokens, it resizes the model embeddings, it sets the chat template, and optionally you can pass resize to multiple. So all these things are done by this simple function. If you have seen my earlier videos, and if you have faced any kind of CUDA errors whenever you are working with different kind of tokenizer models, that is because you added special tokens but you did not resize the model embeddings. So this is one of the challenges you will face, and the setup chat format function takes care of this for you. So I'm going to load the import the classes, and I am going to continue with OPT 350, and I am also going to set up the chat format. So you can see the model chat setup chat format done here, and the model and the tokenizer is appropriately modified. So the setup chat format is going to return a model and a tokenizer. So that's why we are using this kind of a statement here, syntax here. We are going to use Dolly 15K OpenAI style dataset. So let me execute this, and you can see the dataset look. How does the dataset look? So it is similar to how the OpenAI, the ChatGPT output comes. So the ChatGPT output starts with the content, and the role is from the user, and then the content, the role is from the assistant. So the user actually sends a prompt, and then the assistant provides a reply, right? So this is how the setup is, and we are going to use such a data set here. The training arguments, not much of a difference. I'm going to execute that, but if you see here, there could be errors that come from GPT-2 tokenizer fast. So it can say that max sequence length argument is not passed. So if you come across that error, then you need to modify the chat template. So keep that in mind, and you can take a look at the chat template here. Let me print it out. Printing it out also may not make it pretty, but let me try. Actually, we can use the print from rich module. That should make it a little bit better. Let me try. From rich import print. Let me print it right now. Okay, so at least it's a little bit better, but not that great. You can see that we are going to get the various messages from this, because this is a list, you see that, right? So we are going to enumerate on the messages, and then we are going to attach it to the IM start, and we are going to attach to the IM end, and we are going to get the output. So if add generation prompt, then we get the IM start assistant. So this is how the prompt, the chat template is created. And when we are going to use this chat template, we have to first of all use something called as packing equal to true. So only when you use that, the chat template will work properly. So I'm going to initiate this, and the moment I initiate that, the trainer gets ready. So you can see the model is uploaded, and if you go up, you might be still wondering, so how will I know that the chat template is going to be used? What we are doing is we are actually seeing this entire process, and we are giving the chat template to the tokenizer itself. So this becomes part of the tokenizer right now. So when you are going to start the SFTT trainer, the tokenizer is part of the trainer and the model. So you don't need to worry about it. So it will take care of it. And this packing equal to true parameter is required for it to work properly. And then we do the training. And now the training will start. So you can see that the training has started. I'm going to stop this. And next, what we are going to do is we are going to further continue. And this time we are going to use Code Alpaca 20K, and we are going to process this in a different way. So just a second. And that is in. We are going to get the data set. We are going to start the training arguments. And here you can see that we are formatting the functions again, but here we are looping on the various examples. So if you are going to get the data sets as a batch, we will loop on the batch, and then we will create a list output. That is how we are going to process the data set. So you can take a look at this here. And this is done when you don't send packing equal to true. So you saw that we had used packing equal to true here. If you don't send it, then you have to do it like this. So that is what the example here shows. So let me execute this. And the another way is that you can directly assume that there is not going to be any batches, and you can return the modification in your sentences right in the single line, and then you can return it. But you have to say packing equal to true here. So once you do that, then this kind of a format you can use. If you don't use packing equal to true, then you need to use the for loop enumeration. So basically the packing equal to true avoids you writing additional code. So that's what this particular training does. Moving forward, we are further, it's going to be another one or two more. This time we are going to use LoraConfig. So we have started working on quantized model. So how fast we have come across to quantization. We are going to use the quantization process right now. So I'm going to use IMDb dataset, and we are going to use this particular config, LoraConfig, with rank 16 and alpha as 32. So if you guys are new to using LoraConfig for fine tuning, the earlier video in this series discusses about that. Take a look at that. So PFT config, I am initiating it, and training arguments is same. I am not changing it. And when you are going to send the SFTT trainer, you are also going to send the PFT config. And we are going to pull Eleuther AI GPT Neo 125 million. So with PFT takes 3.8 GB for training. So you can take a look at this. I'm going to load it, and once the model gets loaded, you can see that it is going up to 5.2 GB. The model takes 3.8, and when the training starts, it's going to 5.1 GB. So all these things you can see, and you can see it's pretty fast. Even though the batch size is very less, but still it is appreciably fast. I can actually increase the batch size to a little more higher also. I am using batch size of 1. I can go up to 4 if I am not wrong. So you can try these things, and you can see which point you can go. And so apart from this, we can also work on, let me stop this kernel. So moving forward, the similar kind of a LoraConfig we are going to implement, and we are going to create a 8-bit training adapter. We are going to use 8-bit model loader, and then we are going to send that config also. So you can try to modify that, and you can train it. It still works. So this is one of the thing. And next comes the flash attention. So there is a concept called as flash attention. And in order to use the flash attention, you have to first of all do pip install flash attention in your virtual environment or in your Python environment. And then you can use this attention implementation when you are loading the model itself. And then the model becomes flash attention 2 capable, and then you can use that for training. Okay, moving forward. So you can use something called as model creation utility. The model creation utility is possible from the model config class that comes from TRL. So you can see that it is imported from TRL, and you can give the model name, which is going to be the reference model. And from that reference model, you can actually start working on your own implementation of it. I'm not going to dive into this process of modifying your model and trying to work with a different kind of application. But the most important point is that you can modify that and you can create a new model, and you can train it also. So in this particular video, we have seen how the LLM fine-tuning can be automated using SFT Trainer. And we also saw that how simple it is to work with different kinds of configuration in SFT Trainer and make the training happen in matter of seconds. You are not going to write even 10 lines of codes. You are just going to create one or maximum two classes, training argument class and SFT Trainer class, and then you are going to call the trainer. It's pretty awesome. At the same time, it's pretty fearsome also, because think about it. People today, if the documentation is good, and even in the documentation you see there are certain challenges which is not very clear. If you don't know about the training arguments, even if you try to run the SFTT trainer as per the documentation, it will not run, because you have to give the training arguments and ensure that your batch size as well as your evaluation and training batch size is in a appreciable level. If it is more, then it is going to give a out of memory error. So these things are something that we need to look forward to, because you need to understand what is going on inside the classes. You need to understand what kind of methods and what kind of activity is implemented inside the class code. So that is the intention of my videos, and I hope that you like this video, and do leave a like and subscribe to my channel. Next, we will be diving into reward trainer and PPO trainers. So that will be the next thing. Till then, have a great time and start fine tuning. Have a great time.